it's Jim from jetsonhacks.com. Today we are going to install the Go programming language onto a Jetson development kit. Once Go is installed, we will write a little I2C library to interface with a 7-segment display, and then write a little web server to broadcast the results. Let's get started. The first thing that we want to do is install our live I2C tools. Let's check to make sure that the Jetson can see the 7-segment display on the I2C bus. It's installed on bus 0, so we'll take a look there. A gander, as it were. There it is, number 70. Looking good. Okay, let's install Go. This is version 1.6. Now it's time to set up the work directory for Go. Make directory -p. I will call it Go work. Now let's modify our -rc file. We will set our Go path. Go work. And set up the path to the Go binary. Save that. And let's open that up again. That will resource it. The Go tools have a GitHub Wrangler, so you can ask it to go get things from GitHub. Go get github.com. This will get from GitHub on the Jetson Hacks account the Go I2C repository. And that error is okay. So now when we go look in our Go work directory, source, GitHub, Jetson Hacks, Go I2C, we can see that it imported some stuff. Today we're going to work on the I2C example server. This example contains two major parts. One is an I2C interface and the other is a web server. So let's take a look at main.go. There are a couple of things to pay attention to here. This is just a sketch of some software that I wrote. It's not production quality, but it gets the ideas across. The first thing to look at is this OS signal, which is a channel which captures sigterm, sigint. That's what happens when you hit Control-C. And basically, we're going to capture that signal in a channel, which is like a green thread, if you're familiar with that term. And we're going to signal to the program that we actually caught one of those signals. So the first interesting point is this little function here, It's going to watch the OS signal channel, and it's going to look for a sig term or a sig int. And when it gets one, it will say to this channel, the done signal is true. This little part here says run this concurrently. So you can kind of view this as it spawns out of thread and goes off on its own at that point. The next thing that we do here is build a web server. This is going to set up some server-side events for the web page. I'm not going to go over this too much. You just have to go through the code and try to figure out what it's doing. But the next interesting part here is basically you set up a web server on another channel and basically spawn it out. And now we're down to the demo part. We're going to take a look at the LED backpack 7 segment display. We're going to create a new one of those. Ours is running on bus 0, so we'll change this 1 to 0. So if it can't create it, then we're screwed and it throws a panic. This is a rather interesting statement. It's called defer. So when it gets to the end of this particular routine, it's going to close the backpack. So this is pretty useful for cleaning up after yourself. We're going to turn on the display, and then we're going to write a string. And this is a blank string. We're going to wait a few seconds. We're going to write another string, 1, 2, 3, 4. And this is going to write it both to the backpack, which is a 7 segment display, as well as to broker messages, which is the channel that's running with the web server. So let's go look at write string. So just as I said, it writes out to the backpack, and then it communicates with the channel. That's what this symbol does. Writes a string to message channel. Message channel is a channel of strings. And then it spits out a little log message for us. So a couple more things. We're going to do a countdown, and we're going to show a little clock example, and then we're going to show the current minutes and seconds, which is just based on the current time. Let's go over those a little bit. So show countdown is a countdown ticker from 10 to 0. The first thing we do is create a channel called a ticker. And what a ticker does is basically every duration puts out a message on that channel. So I'm going to pick a second. So in this for loop, we're going to block on the next event. So we'll get one of these every second. Then we'll write out a string to both the segment display and the web page. Once we get down to 0, then we'll blink a couple of times. So next we have show clock. Basically this is a clock which shows 9:50 to 10:10. This one works a little bit differently than our countdown timer did. This used a ticker channel for concurrency. This basically just sits here like a big fat pig and sleeps for a second at the bottom of the for loop. When we get to 6:10, which is 10:10 on the LED, then we will return out of this. So the next part of the demo is show current minute and seconds. It grabs the time, grabs the minutes and seconds out of that time, formats it, and then prints it out onto the sudden segment display and the web pages. Then it waits a second. Then at the end of that, it does something kind of interesting. It basically looks to see if there's a done signal. So you remember that we were capturing the Control-C and sigterm and sigint and all that kind of stuff. So it just checks to see if someone tried to interrupt the program. And if it does, then it returns out of this particular routine. Otherwise, it goes back and keeps on keeping track of the time. And then once you get out of that, someone hit Control-C, it will print cleaning up and done. And it will also do the deferred routines at that point. So let's give it a spin. Okay, so let's make sure that we save our file after we changed that. Okay, let's build our little program. We go to Go Work Source, Go Install, github.com, Jetson Hacks, Go I2C, I2C example server. Go doesn't print out progress messages. It's basically not very chatty. The only news is bad news, it tells you. So now we go look at Go Work. As you recall, we created Go Work and the source directory. When we compiled our little application, it built this bin directory and this package directory. When we open up the bin directory, we see our server example. Go builds these applications with static libraries, so you don't have to worry about linking. So I can take that program and put it in a new folder. We'll call it something clever like test. So let's throw that over there. The server also has some templates that go along with it. So we'll wander back over there and grab those. These basically are the HTML and JavaScript files the web server will serve. Index and segment display.js. This JavaScript file basically will throw some graphics up there that look like a 7-segment display. So we're ready to run our little application. Let's see how it goes. Switch back over to test. We need sudo for this because we're going to be talking to the I2C bus for our 7-segment display. Moment of truth. Let's open up a web browser. Start up the server and our little application program. Let's refresh our web page. So now you can see that the web page reflects the 7-segment display. And we have a little tablet, which is also tuned to that web page. We'll start it up. This is an NVIDIA TK1 Shield tablet. Just that easy, just that quick.